Hello and welcome back. In this video, Lee is going to begin skeletoning in our ThreadPool class. So
Right.
Lee, why don't you go ahead and get started?
All right. Let's go ahead and go over to our threading folder inside of our Solution Explorer. Right-click, hit Add, New Item. Notice it's not grayed out. We haven't run it in a while, so we're good. We're going to call this class MyThreadPool. So this will be MyThreadPool. And the reason I'm calling it MyThreadPool instead of ThreadPool is because there's already a ThreadPool in existence, so I don't want to be confusing the two, so we'll just call it MyThreadPool.
Okay.
You could name it anything you want. Go in and do some initial cleanup. And we'll make this a public static class. Now we're going to make this static because I don't want to instantiate the MyThreadPool. At any point, we only need one thread pool. We have the ability to queue work into the thread pool, but we don't need to have the complexity of multiple thread pools all doing different things and trying to fight for processor time. So we'll just have one static MyThreadPool. So I'm going to start off with an enumeration. This thread, wow, I really can't spell thread today. Which is cool, as I keep misspelling it the same way each time.
Well, you know.
Yeah, so we're going to have an enumeration that's going to be the thread pool state. This is helpful for debugging stuff. So if you're having a problem and you need to put some debug statements in to try to figure out what your thread pool is doing, this is how we're going to be able to determine what the thread pool thinks it should be doing. So just 4 states: starting, idle, processing, and stopping.
Mm-hmm.
We're going to need some data structures to hold the information. We're going to start off with static read-only, because this is only going to be defined when this starts off. This is going to be our priority queue. While we made our priority queue completely generic, we can make a priority queue that hold anything that we want. This one is going to be a little bit different. We're going to use a func. And I'm not really going to go into what a func is, other than the fact that it is a way that we can pass in a basically functionality where we can pass in a method or anonymous method by doing this.
Okay.
So we're going to pass in an iWorker thread. Well, actually, we're going to get out an iWorker thread from our functionality. Said that wrong. And we're going to call this queue. The next one will be another read-only. This is going to be a list. Now this list is going to be iWorker threads. And we call it worker threads. This is the list of all of the worker threads that are currently running at a given time.
Okay.
I'm also going to need to add system for that. We'll have a static read-only thread. This thread will be called monitor thread. This is the main thread for our thread pool. This is the thread that will be running in a loop until we go to exit the application. Its job is to monitor our available threads, make sure that we're allocating our threads as needed, pulling new threads off of the priority queue when we have available threads, making sure those all get done, as well as tracking when threads have flagged themselves as completed.
All right.
And this is thread, not threading.
I was going to ask, but I figured you'd catch it.
Yeah. private static an array. This is going to be an array of type wait handle. And we'll call this wait handles. And what are wait handle with an N? There we go. Much better.
Nice.
Yep. All right. Now, what are wait handles? Wait handles are a way, or one of the mechanisms that we can use to have a thread signal back or cause another thread to hold until this wait handle has reset. What we're going to do is we're going to use our wait handles as a means to basically suspend our monitor thread's execution until one of them becomes available. So when all of our wait handles are out or allocated and threads are being executed, those wait handles are going to be all tied up. So we're going to suspend operation of our monitor thread, and it's just going to sit there and spin and wait until one of the threads says, I'm done, and it's going to tell or reset the wait handle so that it frees itself. Our monitor thread will then know, oh, hey, I just got a wait handle back. It'll figure out which wait handle just got released. It will remove that worker thread, which will then free up an available thread for a new job. It will then go to the priority queue to get that new thread and then start running that thread.
Okay.
So we'll use that. We need a public. Whoa. I am typing on my other screen. That's awesome. So let's try public static thread pool state. This will be our state. And this will be a get with a private set. We want to be able to query what state we're in, but we don't want any other application to be able to modify that set.
Okay.
Or modify that state. All right. That will take care of our fields and our properties that we're going to need for the thread pool. What I'm going to do now is go ahead and skeleton in our methods that we're going to use, and then we'll come back and start fleshing out the methods themselves in subsequent videos.
All right.
So we'll start off again, or start our methods with a public static int. This is going to be QUEUE. It's got to be one of the weirdest words in the language. QUEUE. But I still think it's cool.
Yeah.
So we're going to have a Q count. And this method's job is determining what our total number of worker threads are in our priority queue. So that will be its job. Next is public static int get max threads. Now the reason I could implement these as fields, or not fields, but properties. But the reason why I'm implementing these as methods instead is that I'm trying to stay consistent with the ThreadPool's API. So if you look at the way ThreadPool has things, so if we looked at the built-in ThreadPool, so ThreadPool, their ThreadPool is instantiated though, I believe. So, oh really? Come on. Bar. Oh. Yeah. It matters where you put that. Oh, no, it is static. Was I typing that in the wrong spot too? Bet it was. Yeah, it was. All right. So get max threads. Hey, I lied. No, those are properties and not methods. So I lied. All right. Well, let's just to keep things consistent. I know this will bite me later, but we'll make these properties then.
Okay.
I like pain. Besides, I haven't, winged it in a little while.
Okay. All I can do is go with you, man.
Just nod your head and say, "Yep."
That's something like that, yeah. But I mean, when it does bite you, I still reserve the right to, snicker.
Oh no! I fully expect you to.
Yeah.
Go ahead, laugh, point your finger.
Mm-hmm.
So going, why'd you bother to do that? All right, so. So what people don't realize is it's been a while since I've looked at this code.
Oh yeah.
Well, I've been working with Nelson on the other stuff on that storage system for a while.
Mm-hmm.
So this has been done. Wow, this is how long has this been done? Probably technically before we even started the MMO class, because I wrote this last year. All right, so now we made a get an available thread, so we can query our queue count, get the maximum threads. This is how many. What is currently the max number of threads that the thread pool can allocate? Get available threads is the number of threads that are not currently allocated or doing something.
Okay.
So that's the difference between those two. We'll have a static constructor, which will be static MyThreadPool. Static void run. This is where all the goody stuff happens.
Mm-hmm.
So where all of the management of the thread pool is going to happen is going to take place inside of the run method.
All right.
We'll have a public static. Now, this is our QUEU work item method. This is the one that I showed when I brought up the thread pool.
Mm-hmm.
This is how you add things into the thread pool to be worked on at a later time.
Okay.
What we're going to be sending in is an anonymous method that returns an iWorker thread. I'm going to call this worker thread. And we also need to take in a priority. So we're gonna take a queue priority in. Mm-hmm. So this is how we're going to determine what priority that we need to run the worker thread. Now the reason why we're sending in an anonymous method that returns a type worker thread will come up, and I'll explain that later. But for now, just trust me. Yeah, just go with it. It's easier once we start coding in the code. Yeah, there you go.
There you go.
Set max threads. And we're just going to pass an account here. All right. This is how we're going to be able to set our max threads. Now, we can't just change a number because we're using an array here of wait handles. Mm-hmm. And we have a list of all of our threads that are currently being worked. The reason why we have to do set max threads this way is because of the way we're dealing with wait handles. Wait handles being an array means that we're initializing this array to a size. But if we change our set max threads, we're going to have to resize our array. So we need to have a method to do that. So that's why we're putting set max threads in its own method. And I'll show you how we'll resize the wait handles in an upcoming video. But this is the initial skeleton that we're going to need. There's not a whole lot to it yet.
Yeah.
Once we start implementing the code inside of Run, this is going to grow. But again, once it's all done, you're going to be like, that's it.
Yeah.
So, but next video, we're going to start coding in some of the base utility functionality, mostly these three guys. We're going to implement QCount, get max threads, and get available threads.
Okay, sounds great. Then that will wrap things up for this video. Thanks for watching.